There are three formulas we have for exponential growth and decay. These first two formulas are going to be used in almost every situation, exponential growth and decay. There's a third one that's going to be used in one very specific situation, which is just for compound interest. And we'll see the difference in these problems as we go through. One thing I want to point out about these exponential growth and decay formulas, if you look at them, they're nearly identical. The only difference between growth and decay is this plus and this minus. And it should make sense to you that in the growth formula, we have a plus sign because things are growing or increasing. And in our decay formula, where things are decreasing, we're going to have this minus sign. Now, down below here, I've listed what each of these things stand for. And I just want to highlight one thing, and that's the rate. Okay? Things are going to increase or decrease at a certain rate, and a lot of times this amount will be given to you as a percent. Before you can use it in your equations, you have to change it into a decimal. Okay? So you're going to have an ending amount, a starting amount, your rate, which you'll change to a decimal, and then an amount of time. Now in our compound interest formula, we've got a lot of the same things. This A is our ending amount. That's like the Y that we had over here. And the P, our starting amount, that's like the C that we had over here. We still have a rate, which has to be a decimal, and we still have an amount of time. The new thing that we have in this problem, though, is we have this N. Okay, and the N stands for the number of times your interest is compounded. And in your problem, if you have a compound interest problem, it'll specifically say something like the interest compounds quarterly. Quarterly is 4 times, so what we would do is we would take that value of 4 and plug it in for N here and here. And you'll see this when we actually do these problems. But let's start with just basic exponential growth. The number of Facebook users increases, that's what tells me it's growth, by 25% every year. That's my rate, this 25%. The first year it started, Facebook only had 575,000 users. That's my starting amount. And the question is, how many Facebook users, that's going to be my ending amount, were there after 15 years? There's my amount of time. So all the pieces of information that I need are right here in this question. And since it's growth, increasing, we're going to use this formula. So let's start. We don't know how many users there were, how many Facebook users there were, so my ending amount is going to stay a variable. But what I want to plug in for C is my starting amount, 575,000 users. And then I have my 1 and my plus, and then my rate. Now my rate was 25%. I can't put that in as a percent, so I have to remember to change it to a decimal. And remember, your rule is to move your decimal point 2 places to the left, and that will change your percent to your decimal. And the amount of time I have is 15 years. So I'm going to plug in that 15. Now once I've made all of my substitutions, this is strictly order of operations. And the good news is we can let our calculator do all the hard work for us. So step by step, first things first, we're going to add. Okay, 1 plus 0.25. Oops. Let me actually show you how to do it just in case. 1 plus 0.25. Okay, that's going to equal 1.25, which you probably could have done in your head, but no worries. The second thing I'm going to do is I'm going to raise this to the 15th power. Now here's the thing about these problems. I don't want you to clear your calculator anywhere through this problem. When we write things down, we might write like a shortened form of a big long decimal, but I want you to leave the amounts in this calculator so that you're still getting an accurate calculation. And here's what I mean. If I take this 1.25 and I raise it to the 15th power, look at this decimal that I get. So what I'd write over here instead of that whole decimal is I'm just going to write 28.4217. Okay, now I just kind of chopped off the end over here, but that's okay. This tells me when I look at your work that you had this big long decimal. Now in this next step, I don't want to type in this short form of the decimal. I want to leave this big long number. So again, don't clear your calculator. Just hit times and then plug in the 575000. Okay? And hit enter. And now you'll see you have this big long answer, and now we can round the problem. So let me write this down. At this point, y equals 16342,482.92. Now it's a word problem, so we are going to be doing some rounding here. And the question says, how many Facebook users? So this, I know, is referring to an amount of people. Okay, because these are the number of Facebook users we have. And we can't have fractions of people. So what I'm going to do is I'm going to use this to round up. So what I really have is 16342,483. And once I put my commas in there, I can see that I have 16,342,483 people. And now that I'm all the way through the problem, now I can clear it and get myself ready for my next problem. Okay, exponential decay. A new car worth $32,000 loses, that tells me it's decay, 15% of its value each year. How much will the car be worth after 8 years? So what I want is my decay formula. And let's plug into it. We don't know our ending value, but we do know C, which is my starting amount, 32,000. So I'll plug that in here. And then I've got my 1 minus my rate. My rate is 15%. Don't forget we have to change that to a decimal before we plug it into our formula, so 0.15. And I want to know how much the car will be worth after 8 years, so my amount of time is 8. Let's go to the calculator now. First things first, order of operations is what's in parentheses, so I'm going to do 1 minus 0.15. And that tells me that y equals 32,000 times 0.85 raised to the 8th power. Next come my exponents. So I'm going to take this and raise it to the 8th power. And this, again, we see we get one of those big long decimals. So, when I write it, let me get my 32,000 here. I'm not going to write that whole big long decimal, I'll just write part of it. 2724. Okay, and again, I didn't round, I just kind of chopped it off. It tells me that there's more to it. I know that by looking at this, but I can see that you have the right answer. Leave this here, and then just multiply it. Last step, multiply by 32,000. And hit enter. And when we do that, we get that y equals 8719.696. Now again, I know this is a word problem, so this has some value to it. This wants to be how much will the car be worth, which means this is a money amount. So I have to round this to an amount of money. Okay, it's $8,719, but I need to figure out how many cents I have here. So I'm going to take this 6 and use it to round up, and it'll give me 70 cents. So the car will only be worth $8,719.70. Okay. The last problem I want to do with you is going to be a compound interest problem, and here's the difference. If you have a problem that you put money in a bank and it just says the interest is annual, one time a year, you can use the other exponential growth formula. It's only when you have interest that's compounding more than once a year, and in this case we say quarterly. So here's our situation. You deposit $10,000 into a bank account that earns 6.5%, that compounds quarterly. How much money will you have in your account after 20 years? Well, the compound interest part of this, compounding quarterly, tells me I want to use this other formula. So my A is my ending amount, which we don't know. The P is my starting amount, which is $10,000. Then I'm going to have this 1 plus R, which is my rate, 6.5%. And remember, we want to change this to a decimal, move that decimal point 2 places to the left, and we get 0.065. So 0.065. And all of this is over N. N is the number of times my interest compounds every year. Right here we're told it compounds quarterly, which means 4 times. So my value for N is 4. So this N down here is going to be replaced with a 4. This N up here is going to be replaced with a 4. And then we want to know after 20 years, so my value of T is 20, so I'm just going to stick that up there too. Okay? Now again, At this point, we just have order of operations. So we'll start off, A equals 10,000 times 1 plus, the first thing in my order of operations that I'm going to do is this division right here. So 0.065 divided by 4. And that gives me this answer. So what I have is 1 plus 0.01625. And then I'm going to do this really quickly. This 4 times 20 means eventually I'm going to raise it to the 80th power. Now, next step in order of operations, what's in my parentheses? So I'm going to take this decimal and I'm going to add 1 to it. So I have 10,000 times 1 plus, I'm sorry, not 1 plus, 1.01625 to the 80th power. My next step is going to be to raise this to that exponent of 80, which gives me 10,000 times 3.63115. And again, I'm not going to write the big long decimal. I'm just going to write part of it, but I'm going to leave it in my calculator so that when I do times 10,000, it'll calculate with that big long decimal, and the answer I get here is 36311.541. Now again, we're talking money here. This is a money problem. So I know this is an amount of money. So when I round it, I need to figure out how much this would be, and this 1 is not going to change that, so it's just going to stay 54. So after 20 years, I would have $36,311.54.